We're going to look on page 54. Now, I want to call your attention on page 54 where it says polygons.
Mm-hmm.
And it says, if you notice where the italicized polygon is, and right after it says, is a simple closed figure composed of line segments, so straight lines. But then you look back at that simple closed figure on the previous page, and then if you look at that, it says that closed figure, and if you toward the end of that sentence, trace so that the starting and ending points are the same, and no part of the curve is crossed or retraced. Now that's important to put those two together for a problem or two. So you can't, a polygon is straight lines, but you can't retrace it and you can't cross them.
Mm-hmm.
So you want to take that into consideration.
All polygons are closed curves, but all closed curves are not polygons.
No, a polygon is a closed curve.
Mm-hmm.
But a closed curve, you have to realize a closed curve, you cannot retrace anything, nor can you cross it. So if you think about a polygon, the straight lines, then those straight lines, you can't cross each other. You can't retrace them. So what you said was right, but the thing that I'm pointing out is just remember that when you're talking about a polygon, if it's straight lines and the straight lines cross, it's not a polygon because it has to meet that criteria of a closed figure also. Okay. Then there's definitions for types of polygons, and triangle, quadrilateral, and it says how many sides there are. And then notice that second one, quadrilateral, that has 4 sides, so then you have 4 different types. A square, all sides are congruent and all angles are right. A rectangle, all angles are right angles. Now it doesn't talk anything about the opposite sides are congruent, but it makes it that way if you have all right angles. Now the rhombus, notice, is all sides are congruent. You don't have, the only difference between a square and a rhombus is you don't have right angles. You have the congruent sides. On the parallelogram, opposite sides are parallel. So a rectangle is a parallelogram, but all parallelograms are not rectangles because you don't have that 90-degree angle. Trapezoid, only one pair of sides are parallel. And then an isosceles trapezoid is one where you have parallel lines and then the lines that aren't parallel are equal or congruent. Then a kite is exactly as you would think a kite would be, right? The shape of a kite. So the top 2 sides are congruent and the bottom 2 are congruent. So, and it's showing you pictures of it on the next page. And then they're talking about symmetry. And symmetry is, if you look at the bottom of the page there on 56, you can see it's the line for which you can rotate it around. In algebra, we called it axes of symmetry. If you hold it on that line and you rotate it around it, it falls back on itself. And it's showing you that a triangle, that isosceles triangle, has one axis of symmetry. The rectangle, the square, has all those different axes. And then an equilateral triangle has 3 axes. And then an isosceles triangle has no axes. Now there's that kind of symmetry, and then on the next page, it's called rotation symmetry. And that is around a point. Reflection symmetry is rotation around a line. And reflection symmetry is, and it has an axis. Rotation is, it's around a dot, and you can see that you're taking that equilateral triangle and just, you can rotate it around and it'll fall back on itself. And then they're saying that there, that figure 2.34, which is a trapezoid, that don't have rotation symmetry. So some things will have rotation symmetry. If it takes one whole rotation for it to fall back on itself, then it does not have rotation symmetry. But if it can fall back on itself in less than one complete rotation, then it has rotation symmetry. Okay, so what we'll do is we'll look on page 58. And I guess it's actually 59. In problem number 2, it says the several triangles are shown with congruent sides. Now, congruent, the standard thing is when to show congruency of sides and angles. If you grant me that those two triangles are the same, they would fall one on top of another. So what you would do to show that the angles are congruent, you know, you do like that. You could show that this one is congruent to that one, and then you could also show congruence by just drawing a single line.
Congruence is just another name for different line.
Congruent means they're equal.
Right.
And then like this side is congruent to this side, but you could show congruency like this side is congruent to that. So just, if you're doing congruency, you can use doubles or singles or things like that. So you notice that for those triangles there, you can see which are congruent. Congruent being that they're equal. So number 2, then it says which triangles are scaling. Now scaling means no sides are congruent. So the triangle.
Yes, HGI then?
Yeah, the triangle HGI is, there's another one. Okay, MON, right? Okay. B.
Now, Professor, is there a way to completely determine that on MNO, or is we're just eyeballing?
What it is, notice that each of those triangles, if the sides are congruent, they've drawn lines like
Okay.
A, B, C, those
Gotcha.
3 sides are congruent. So they've drawn a single line in there for the next triangle. It's an isosceles, the 2 top
Gotcha.
sides are congruent. And then the G, K, you see there's 3 little lines through there. And then on that last one, that equal angular one, the PRQ, those angles are all the same, so I got a single line. That's what that means. And then right triangles have the little square box in the end. Okay. So let's see. Which triangles are isosceles?
Mm-hmm.
Okay,
AJL,
triangle D, E, F, and triangle, let's see, L, K, or what, J, L, K.
mm-hmm.
Now, isosceles. Read the definition. The definition, isosceles triangle. At least two sides are congruent. Do we have all the isosceles triangles listed? At least two sides are congruent. At least, can there be three sides congruent?
Ah,
At least two. So the equilateral can be isosceles. Do you see how it's defined? At least two. So you could say two or more, right? You see what I'm saying?
mm-hmm.
Triangle A, B, C.
Isn't that just a matter of semantics?
I know, but the other thing is it makes A, B, C an isosceles.
Right, but you would not classify that.
Well,
Can be,
it's isosceles by definition. Because the way you define it, you know, I mean, that's the way you define it, that equilateral is also
right,
isosceles.
goes at least two.
Yeah.
Gotcha.
All I'm doing is I'm just pointing out to you that.
Yeah, don't kill the messenger.
Yeah. Okay, then C. Now this is more obvious. Which triangles are right triangles?
Just the one.
Are you sure?
Oh, no, two, that's right,
Yeah.
that's right, two.
J, K, L, and triangle M, M. Start over again there. M, O, N. Because each of them, all right triangle has to have, it has to be a polygon, three-sided, and has to have a right angle in it. Now, E, which triangles are obtuse? Obtuse, what does it have to have? An angle greater than 90, right? Is there such a thing there?
I think so. There's right.
I guess, you know, it just depends. It could be. The book is saying it isn't, but that, if any of them could be, that one could be.
Which one?
HGI. It'd have to be one like that. It couldn't be a right triangle because right triangle, then the other two angles have to be acutes. So it has to be, and it, you know, it can't be equilateral, it can't be isosceles, it has to be a scalene.
Which one is the one of equilateral? Is it equilateral?
It's ABC.
Oh, I didn't do D, did I? So, the E is, you know, up for grabs. The D is triangles equal angular. So which one's that one?
Is it, are they asking for equilateral or?
PQR,
PQR are all angles are equal, but is there another one?
ABC.
ABC, yeah. Because if it's equilateral, then it has to have equal angles. But if it's equal angular, it doesn't have to have, well, it has to have equal sides if it's equal angles.
Right.
The thing that you can't do if you remember congruence, you can use side, side, side to prove two triangles are congruent, but you can't do angle, angle, angle.
Why?
Because two triangles can have the same angles, but have different lengths of sides. They can't be different triangles if the sides are all the same. So, for example, if you can make a triangle that's equal angular. If you grant me a little bit of slack on this thing, and let me just say that those angles are equal. Now, you can draw another triangle.
So, I'm trying to say on the,
The angles are equal, but the sides are not.
But see, if two triangles have congruent sides, they're congruent. Side, side, side is a proof for congruency of triangles. But angle, angle, angle does not, angles being equal is not congruency of triangles.
Different sizes.
Yeah. If you remember back in geometry when you took it in high school. Yeah. Okay. So that's example of one equal angular that isn't congruent triangle. Okay. So the next one is draw examples of the right scalene triangle. So it's got to be scalene. It's got to be a right. So if we drew a right, then what I'm doing is this is a right, and then all three sides have to be different lengths. So that would, I think it's pretty obvious, all three sides. So that's a right scalene. A right isosceles triangle. So I can if you grant me that this length and this length are the same, and this is a right angle, then that's a right isosceles. Two sides are equal. It might not be, perspective it might not be, but that's a right isosceles.
and you just have to show with the line, right?
Two side isosceles says, if you look at the definition, at least two. So I could have drawn, I don't know, like you can't draw an equilateral right
It's
triangle
impossible.
because each angle has to be 60 degrees. See, isosceles says at least two sides are congruent. So I've got at least two sides. If you grant me they're the same length. Okay, obtuse isosceles triangle. So all we have to do is make one of the angles greater than 90, and then what I want to do if you grant me this, that this side and this side are congruent, same length, then when I join this, then that's an obtuse, because this angle is greater than 90, and it's isosceles. Now, D, an acute right triangle. What's an acute definition of an acute?
All less than 90, it's not possible.
Yeah, because a right triangle by definition has a 90-degree angle. So you already have one angle that's equal to 90, and they all have to be less. So number 6. How many different isosceles triangle can you form using 24 toothpicks?
Jeez.
Well, 24, if your base side is one toothpick long, then you have 23 toothpicks left, and you can't get an isosceles, right? So you can't have one. Can you have two?
Mm-hmm.
So you'd have 2 toothpicks, and then you'd do 24, and you'd do 12 and 12. Now,
11 and 11.
11 and 11. Okay. But now think about that. If one is 11 long, and the other side is 11 plus 2 long, can you do it? Yeah, you can. Can't you? So 3 is not going to work, right?
Any even number.
So 4. Well, the only thing is it any even number. 4, then you have 20 is 10 and 10, right? 5 won't work. 6. 6, you could have what?
9 and 9.
9 and 9. 7 won't, and 8.
You can make equilateral.
Can you have 10?
7 and 7. Now, at what point will the base become too big to
Yeah,
complete the triangle?
that's what you got. That's what you have to worry about. So can you have 12?
6 and 6. Will it work? We have to measure it out.
Well,
So
if one side's 6 and the other side's 6 and the other side's 12, what you've done is you'd laid 2 sides 6 and 6, and then it's 12. You can't do it, right?
Right.
One side is 12, and you have 2 6. They're laying right on top of each
Right,
other.
they'll never
Yeah.
meet. That's it. So 10 is the break point.
Yeah.
Interesting.
Okay, B. How many different scalene triangles can be formed using 24? So scalene is all sides are different. So can you have one side is 1, and then
Mm-hmm.
how would you divide it up? 1 and 23,
12 and 11.
but what about that? If you have a 12-inch side and 11 and a 1,
Don't make it.
don't make it, right? Okay. So does a 2 work? Got to be scaling. They got to be different. 2, then you'd have 22 left. So they'd have to be different sizes.
This is the opposite of the other problem. We have to have a minimum base somewhere. How do you figure that out? 'Cause that won't work either. If 2 is on the base, then 11 and, nope, 10 and 12. won't work.
10 and 12 won't work. Right? You can't have a 2, can you? So that won't work. A 3.
10 and 11.
So a 10 and 11 would work, wouldn't it? Is there another 3 that would work?
Maybe 9 and 12, would that work? See, it's hard to determine.
Yeah, see, 9 and 3 is 12, and the other side's 12, won't work. See, if you did 9 and 12, then you'd have a 9 and a 3 and a 12. 9, 3, 12 falls on itself.
Okay,
Okay, so that does it. How about a 4?
maybe 9 and 11, I guess.
Okay,
You can't do 8 and 12 because the 4 and the 8 would collapse on
Yep.
each other.
yeah. So you're done, right? You good?
Yes, so,
Saying when you go further, it gets worse, right?
right, they won't need it all.
Okay, 5.
19 left.
You-
10.
Okay,
8 and 11.
okay. And then the only way we do is 7 and 12. But what do you got?
Collapse.
You're done, right? Then 6.
10 and 8.
Okay.
No, doesn't work.
Because that's an isosceles.
Right. 11 and 7.
Does that work?
Should.
Okay,
12 and 6 won't work. I think that's it.
yeah. So then a 7.
17 left.
Isn't it, yeah, 17.
9 and 8. You can't do 10 and 7 because then 2 sides will be equal. 11 and 6.
Is this adding up?
Yes. You can't do 12 and 5.
You see this right here? one of them gotta go.
Right,
Right?
right, right.
Is there anything else?
No, it's 12 and 5 won't work.
No, but is there, the 7, 8, and 9 work, so,
Can you do 13 and 4? No.
no, 13, you see 7 and, you're saying 7, 13, and 4? See, the 7 and 4 is 11 and you couldn't make it. I think you're done with the 7s. Now, if you go to 6s, you got 6s that work, that are here, right? And then 5s, you got the 5s that are working here, so on. So you're done.
That's 7.
Hey, this one is duplicated right there. That's why. Okay, then the C, how many different equilaterals? All sides equal.
Just one will just divide. Anything that can go to
Yeah, there's one, it's an 8, 8, and 8, right? It's the only one, all sides equal. I mean, it has to be 3 times x has to equal 24, right? So x is gonna have to equal 8, so. Now, 8 and 10, I'm not gonna do those, that square lattice, that is, I don't know.
You can spend an hour on
You can,
that.
and then 10, where it says modify the figure from problem 9 so that it forms non-simple closed figure. There's infinite number of them. So, I mean, it's not anything that I'm gonna give you as a problem. So 12. So it says, given the following simple closed curves, draw an example if possible where they intersect in exactly the number of points. So 12A. 1 point. My circle isn't too good. 1 point.
So everyone is like this. What are they looking for?
If you did something like this, it's 1 point right there, isn't it?
Okay.
Okay, 2 points. So being we did that one, then 2 points. If I just move that triangle up, then it's 2 points, isn't it?
Mhm.
3 points.
What if you draw the 3 on the inside?
Okay, so if you if you'd make it go like this.
Yeah.
So that'd be 3 points. Oh, it just looked like it should have that on it. D, 6 points.
Same as C, but increase the size of the triangle.
Okay. So you're saying 6. Now, if you did something like this,
Yes. Has to go beyond the circle.
1, 2, 4. Gotta go down. I gotta go down a little
That's
bit more.
it.
Each corner has to be outside of those.
But isn't that 8?
No, that'll be 6.
Yeah, no, it's
Just a little too long.
Well, let's see. Here's,
That's it. Oh, perfect. 6 points, sure.
okay, that's. Now, 14. This is the one. It says, which of the following shapes are polygons? Now, what you want to do is you want to look at back on that page 54 and 53. A polygon is a simple closed figure composed of line segments, so it can't be curved. It's got to be a line segment. And then the simple closed figure, no part of the curve is crossed or retraced. So 14. And it's just like, is it a polygon or is it not? A, is that a polygon? No, because it's not line segments. It's curved. B, is that a polygon? So that is. C, is that a polygon? Okay, it's no. See, they're crossed. They're line segments, but they cross. And then D, yes, and E. And that one is,
Well, nothing is crossed, nothing is retraced.
Nothing is close to nothing.
but how would you, see, when you list the polygon, this is, how are you going to list it? Polygon has got to be, let's leave that extraneous piece on there. Here's, no, oh yeah, one more. A, B, C, D. And now you got to list it out in succession of points going around the polygon. So how are you going to do it? A, B, C, D, and B, right?
Can you do that?
But only is it it doesn't meet the criteria. See, I mean, you have to list it as it goes around. It's not. If you notice underneath, on page 54, underneath the figure 2.29, polygons are named by listing the vertices in the order around the figure. So you see, you can't list the polygon as A, B, C, D. It's gotta list every line segment. And then it has, then there's another thing.
Notice that in a polygon, the number of vertices is the same as the number of sides.
Yeah.
So that DB, line DB,
Yeah.
I think that's it right there.
Mm-hmm.
That's interesting. I wouldn't say otherwise.
Yeah. And then the closed figure, and it says, simple closed figure is a figure that lies in a plane and can be traced so that the starting and ending points are the same. So you can't do that either. So it's a no. You know, to me, I wouldn't be, I don't think I would not tend to use that kind of a question to, now 16 just says draw 2 copies of the hexagon shown. This is gonna be tough to show. Now, all those sides are supposed to be the same length. Divide one hexagon into 4 identical trapezoids. So all the sides are the same. So if you do,
You could draw 3 horizontal lines, midpoint, and then half and half, and then you'll have the 4 tracks. Uh-uh.
1, 2,
I guess.
that's 1.
So there's multiple ways. Oh, 4 identical trapezoids.
Yeah.
Never mind, my mistake.
Yeah.
My mistake.
Okay. Then divide the second hexagon into 8 identical. So this one is A, B. Now this, because I don't know how to draw these things identical. It's going to
Why
be hard.
not divide them like, I don't know, like from both ends?
Have
you divide one into two, like from the side, and then you see up to the
I can't do these in different colors. If you do something so that inside here,
And split the middle one in half.
and then you split this thing
Cool.
like here. Theoretically, they should be all the same. There should be 8 of them. You should have 1, 2, 3, 4, 5, 6, 7, 8. I mean, it's hard to draw that because I guess I should have made it bigger.
That was
Alright.
their idea.
Then 18 is where we'll start next.
Pick it up on Monday.